Alright, today we're going to do this section 5.4. I have to go in a little quicker because my first take was too long, so write fast. Your objective is writing equations of lines in standard form. So writing equations of lines in standard form. Now standard form I'm going to abbreviate as SF, standard form. Alright, you had these three linear equations already. I'll brief them again. The first one is slope, y-intercept, and that is when you have y alone, looks like y equals mx plus b. The m is your slope and the b is your y-intercept, where it crosses the y-axis. Number 2 type, you had point slope form, and that looks like y minus y sub 1 equals m times the quantity x minus x sub 1. The point that you're going to put in is in the subscript position, and the slope that you're going to put in is in m. The third is what we're learning today, and this is standard form. And standard form looks like ax plus by equals c. You have x and y on the same side, as well as no fractions. Okay, let's move to examples. First we have 2 points. We are going to find the slope. Y is up, so y minus y, negative 3 minus 5 over 4 minus 2. Gives us negative 8 over 2, slope is negative 4. Pick a point. So we're going to put it into point slope form. So I'm going to go plop, plop, plop. There's an x of 1. Sorry, I'll erase that quickly. And you have an x sub 1. Okay, so I plug in y minus my y coordinate equals my slope, and then x minus my x coordinate. I'm going to distribute this negative 4 to both terms inside your quantity, and you will have y minus 5 equals negative 4x plus 8. Move the 5 over so that y is alone. You have y equals negative 4x plus 13 if you add 5 to both sides. You are not in standard form yet. To get in standard form, where x and y are the same side, move your x to the left. So you're going to add 4x to both sides. 4x plus y equals 13. Finally, you are in standard form. Standard form. You had to work through point slope form. This one, y is alone, is slope y-intercept form. And finally, you got to standard form. Alright, next equation, or next example, you have to find the slope. M equals 3 minus negative 2 over 0 minus negative 1. Numerator is a 5 because this is plus a positive. Denominator is 1. So it turns out that your slope is 5. This point, hopefully you were waiting to tell me, is your y-intercept. So you're going to have y equals mx plus b. You have the slope and you have the y-intercept, but you're not in standard form yet. So move that x to the left by subtracting 5x from both sides. You have negative 5x plus y equals 3. Voila, standard form. Okay, next examples. You are running for class president. You have $30 to spend on publicity. It costs you $2 to make a campaign button and $1 to make a poster. Write an equation that represents the different number of buttons, x, and posters, y, you can make. Graph the line to represent this information. Let's let x equal number of buttons and y equal number of posters. Okay, now you have a cost situation. It's going to cost you $2 for every button and $1 for every poster, and you have $30. Excuse me. Alright, let's get our y alone. Subtract your 2x, and you'll get y equals negative 2x plus 30. And to graph that, I'm going to take this and look at this as being my first quadrant. Here's your there's your y-axis and your x-axis. and here's my y-axis. And I'm going to go by increments of 2's. So 2, 4, 6, 8, this is 10, 20, 30, 40. And on the x-axis, same thing. I might have messed up on one. Okay, the y-intercept is 30. Start on my y-axis, then I'm going to go down 2, which these are all by 2, so go down 2 and over 1. Down 2 over 1. So you can start seeing that these are the points. Maybe I'm not doing this completely correct. Let me start that again. I went down 2 over 1, over 1, down 2 over 1, down 2 over 1. So this looks like it's going to be 15 here. So if I draw that. Now all the points on that line satisfy this buttons and poster situation. So if you're going to satisfy this equation, you can look at all the points on this line. So let's pick a couple of them. Let's pick the ordered pair 10, 10, because 10 over and 10 up is going to be on this line. So put in 2 times your 10 plus 10, does that equal 30? Yes. Put in your 8, 14, because if you go to your graph, you go over 8 and up 14, it hits the graph. And so if you go 2 times your 8 plus your 14, does that equal 30? Yes again. So all the points on your line satisfy this equation, and that's why a graph is important. It's an infinite number of solutions. To the back, you are renting a car from a company that charges $30 per day and $8 per mile. So I'm going to say that my one-time cost per day is $30 and I have 8 cents for every mile. So there's my equation. And for that company, check out another car company that charges a flat rate of $40 a day and write this equation. That means my cost is $40 all day long, no matter how many miles I ride. The last part, how many miles can you drive? That with the first company before the second company is the same cost, and I want you to do it algebraically and geometrically. Geometrically, we're going to graph it. So you have y equals 0.08x plus 30, and if I do a table, when I plug in 0 for my x, I'm going to get 30 for my y. If I plug in a 100, it'll move the decimal places over 2 places, and I'll get an 8 plus 30 is 38. If I plug in 200, I'll get 16 plus 30 is 46. Then the other one, I'm graphing y equals 40, and your inputs, we don't know anything about x. We know your output is 40, so I'll just pick 3 points like 5, 8, and 10. Now when I do the graphing, I have to know what my numbers are going to be so I can get decent increments on my graph. So I'm going to go by tens. So this is 10, 20, 30, 40, 50. Up to 100 here. Here I have 10, 20, 30, 40, 50. I have to go all the way to 200 on my x's, so 10, 20, 30, 40, this is 150, and 10, 20, 30, 40, this is 200. Okay, so then I plot my points on my blue line. I'm going to go 0, 30, and then I'm going to go over to 100 and up 38, which is about here, then over 100 more and up to 46, which is about here. So I'm going to draw this line as best I can, and and then I'm going to go to the green line where all the y's are 40. So I go up to 40, and this is a horizontal line where all the y's are 40. Where they intersect is about here. That's showing you geometrically. So we have done this. We should get that answer. We could get closer on that graph, but I'm going to go ahead and do it algebraically and show that they both will agree. So you have this equation, y equals 0.08x plus 30, and you have the other equation, y equals 40. Since y equals 40, I'm going to put that 40 in for y. I'm substituting for this y. I'm going to replace it with 40, and it equals 0.08x plus 30. Now if you subtract 30 from both sides, you have a 10 equals 0.08x. Divide by 0.08 to get x alone, and x is going to equal 125, and your final answer is 125 miles. That's algebraically. It's easier to see than figuring out on my graph if my line isn't very straight, which I didn't do. You have 10, 20, 125 would be about here. So you have 125 miles, cost $40 for both plans. And that's how you'd find it geometrically. So you've done it both algebraically and geometrically, and they agree with the same answer. Okay, that's 5.4. You're to do your homework in class, so I'm going to check your notes. See you tomorrow.